Okay. Chemical formulas and bonding syllabus 1 through 5. Chemical symbols. What is a chemical symbol? A chemical symbol is an abbreviation for the name of an element. There is usually 1 to 2 letters, and the first letter, if there are 2, is always capitalized, and if it's only 1, it's still always capitalized. To the right, you can see that there are all of these elements, and as you can see, they all start with a capital letter and end with the lowercase letter. And then you can also see that in the periodic table below, how if they don't have a second letter, it is capitalized. If they do, they are capitalized first, and then they have the lowercase second letter. Chemical formulas. What is a chemical formula? A chemical formula is an abbreviation for the name of the compound made with the numbers and chemical symbols. What do chemical formulas show us? Well, they show us what elements are in a compound, and they also show the number of atoms within each element in the compound, and this is indicated by the number in the bottom right next to the element. So as you can see to the left, we have H2O, and the 2 is the number of atoms there are for hydrogen. So there's 2 hydrogen atoms, and then the O, there's only 1, and there's not a number present, so it is assumed to be 1. So that would be 2 hydrogen and 1 oxygen, and then that makes up water. Intramolecular chemical bonds, slide 1. What is a chemical bond? A chemical bond is the force that holds 2 atoms together within a compound. It's an attraction between the positive nucleus and the negative electrons of another atom, and this is what makes them want to acquire a full set of valence electrons in a stable ratio, and you will later see in later slides what I mean by acquire a full set and the stable ratio. But here in this image, you can see we have multiple atoms going through and being held together. Next, we have the intermolecular chemical bonds, slide 2. There are 3 different types of chemical bonds. There are ionic bonds, and these transfer electrons. Here you can see under the ionic you can see that there is this atom, which has the 3 electrons, and this electron is going to be transferred over to this side to give it another atom here to keep a stable ratio of 8, which you will learn about in those other slides. Then we have covalent bonds that are bonds that share electrons. So here it shows there's 2 hydrogens and then 1 oxygen, and here you can see they are sharing their electrons with this oxygen. Lastly, we have the metallic bonds, and these have mobile electrons, which means they can just move freely within this area they're given, and that is shown over here in this bottom left-hand corner. Next, we have the octet rule. What is the octet rule? The octet rule is how atoms tend to gain, lose, or share electrons in order to acquire a full set of valence electrons. A full set of valence electrons is 8, so all electrons are paired. What are valence electrons? Valence electrons are the electrons located on the outermost layer of the atom. So here to the left, you can see this one at top has these 2, 4, 6, and then in this one, you can see that there's 1, 2, 3, 4. 4 sets of 2, which makes it 8, so the valence electron layer is 4. The oxidation number. What is an oxidation number? The oxidation number is the charge of an ion, and this can be positive or negative. A positive is cation, and negative is known as an anion. These are dependent on the octet rule. What is an anion? What is an ion? An ion is an atom or a group of atoms that has one or more positive or negative charges. This is shown over here with the hydrogen having the +1 and the oxygen having this -2. And you can tell if they have a +1 or -2 depending on what group they are in the periodic table, which I will show in this next thing. Okay, types of ions, slide number 1. Monatomic ions versus polyatomic ions. What is a monatomic ion? A monatomic ion is an ion formed by one singular atom. Naming cations, groups 1A, 2A, and 3A metals are known by the name of the element. Transition metals 4A and 5A are labeled by Roman numerals to show the charge modified by the ascending or the ascending. Naming anions, they're going to be nonmetals modified with the ending "ide." Over here you can see that there's the chloride, nitride, and then at the bottom, these coppers would have the parentheses. So for copper 1, you would put the Roman numeral 1, copper 2, you would put 2, etc. Types of ions, slide number 2. What is a polyatomic ion? A polyatomic ion is an ion formed by many ions. These are bonded together by covalent bonds. You can refer back to slide 6 if you need to refresh on that. They form ionic bonds with ions of the opposite charge. Ionic bonds with opposite charges, naming those that are preceded by hydrogen, add the prefix hydrogen or bi to the name of the ion. If more than one hydrogen, add the prefix di, tri, tetra, depending on the number of hydrogens present. Naming those with oxygen, there's the hyporoot, ites, utite, etc. Over here you can see there's the phosphate atom and there's the 4 oxygens bonded there. Elbow rule. The ions that are in elements that are in the elbow are over here. I'm not quite sure why it is covering up right now, but there's boron, carbon, nitrogen, oxygen, fluorine, chloride, bromine, and aluminum. So an 8 ending is going to be simplify that there's 3 oxygens. I is going to be 2 oxygen, and those are when they are contained within the elbow. And then if they're outside of the elbow, it's going to have 8 ending for 4 oxygens, and then ite for 3. Here we have some examples and practice with the chemical formulas. Some common examples are water, table salt, and methane, H2O, contains 2 hydrogen, 1 oxygen. Table salt contains 1 sodium and 1 chlorine. Methane contains carbon and 4 hydrogen. Now we have these practice problems over here, so you can do those and pause the video, but I'm going to continue and show you how to do those. So here we have our element, phosphorus, and then we have our 4 oxygens, and then there's our oxidation number 3. So if you go back to the other slide, you can see here that phosphorus is not in the elbow, therefore, and it has 4 oxygen, therefore it's going to have that 8 ending. Now we have the answer phosphate for PO4 3 negative. Next we have this right here. Our element is going to be chlorine. We have 3 oxygens. When you look back at the slides, if you need to, you can. There are 3 oxygen, and that is in the elbow, so it's going to have an 8 ending as well. So that one's going to be chlorate. Next, we have our S as our element, which is sulfur. Then we have 3 oxygen and 2 negatives. So here we're going to have sulfur, and then this sulfur is not contained in that elbow, so it's going to have the ite ending because of this 3. So this is going to be sulfite. So as I was saying, this is going to be sulfite. Next, we have this element, which is also chlorine, and this is going to have a 2 oxygen because remember, it's going to be that lower right-hand corner next to your compound. So that's going to have 2 oxygen, and chlorine is in that elbow, and that's going to give it the ite ending, so this is also going to be chlorite. Once again, this is more practice. This one is for chemical bonds, naming the ionic, covalent, and metallic. So if you can pause the video here and try it on your own, and then I'm going to continue and explain how you do these. So first we have potassium chloride, and here you can see this potassium has this being shared, which, well, it's being transferred. And if you go back to the other slides, you can see that transferring is going to mean it is ionic. So this is going to be A. Magnesium, if you remember, as I said with those previous slides, there were sharing, or other options are sharing electrons or having the mobile electrons. And here you can see that these are mobile, they can move around. So this is going to be a metallic bond. Lastly, we have ammonia, and obviously there's one more option, but we're going to explain this. So here you can see these are sharing those electrons, which means they are covalently bonding. So that's going to be B. If you skip through that video or anything, if you would like to check your answers, here are the answers. You can pause here and look at what you had and compare. But yeah, thank you.